Hello and welcome to Telco Steve's Workbench. It's a small workbench, but it's because I used to have a large workbench, but then, you know, housing crisis and all that stuff. But that's a whole nother video and a whole nother story. Could go on for hours about that. What we have here today is what is known as an auxiliary ringer. It basically takes the ringing cycle comes in on your telephone. Pick up the phone, ringing stops, somebody calls back in, you would have a contact closure. You can get those from Viking Electronics to wire them up to a transformer. This guy here takes an 18 volt AC input. The transformer is rated at 110-120 volts AC on input, and output is 18 volts at 2 amps. That'd be 2 amp maximum draw. This guy's an 18 volt AC, 60 hertz input on the leads that control the bell. You must use 18 volts AC. It will not work on DC voltage. It will not work on 40 volts AC. It has to be 18 volts. Okay? So with that said, the 2012B, not to be mistaken with the 2012A for trimline phone lights, the 2012B is an 18 volt AC transformer. Have it hooked up to electricity, it's turned off, and when I turn on my power strip, it will ring the bell. So if you were to hook it up to an Viking's electronic contact closure device that would close a contact on an input of a ringing generator at 90 volts AC, 20 hertz, typical Potts line ringing generator, it would trigger a contact closure. You could wire that into series on one of your leads and it would ring the bell. If there's a phone call coming in, on, off, on, off. So that's what we have here. He's got bell system stamped on with a part number of KS-20375-L1. That's a 20375-L1 bell. The bell is listed as an auxiliary ringing device. Bell system had a couple of different other ringing devices and signaling devices that input different voltages. Typically, ringing of a phone is 90 volts AC, 20 to 30 hertz. Therefore, if you were to wire this bell up directly to your phone line, even though you wired it up to the bells, thinking that, oh, it'll work off your phone, it will not. You must have a proper transformer in line to power the bell. So, I can't take responsibility if you don't know basic electricity or you don't know about wiring, or you're unable to figure it out. That's not my job to try to do this for you. My job simply is to show you what we've got and how it works. The bell, this bell, has an adapter on it. You take this screw off. This unit here was typically supposed to be mounted to an adapter. The adapter, which was a KS-20375 List 2 adapter plate, would then mount on an electrical outlet box, a quad, or however you want to say it, a square outlet box. I don't know if you can see the picture or not, but that's what the picture is. Here's the bell, here's the adapter, here's the box. Now, this might fit on directly to the conduit box. So therefore, once again, you see what it is, you see how it is. The holes on the bell, from hole to hole, measure 3 1/4 inches. Let's do it from the top. 3 from top to bottom is 3 1/2. From across, it's 3 1/2. I guess I got my measurements wrong. From across, I'm sorry, it's 3 1/2 inches. From hole to hole. Okay? The bell, total length of it is 6 inches. So it has a coil that drives a plunger that basically goes back and forth and rings the bell. Inside you can also see that there are some other information on the bell. It says 18 volts, again it's AC, 60 hertz. You won't find 60 hertz in DC, don't even look. If you think that exists, don't buy this. 60 hertz, 0.325 A maximum, meaning maximum amps drawn from your transformer. Okay, there you have it. It's for sale. If you know how to wire it up, you know how to do it. Excellent buy. Thanks for watching.